Alright, so today, as I promised you in the past, we are going to find the equation to the line tangent to a curve, usually a parabola, an easier way. Remember how much y'all love that. I know how much Kelsey loved that, and Kelsey's watching the video. So she's missing the fun part. So let's look at this. Let's go ahead and create a curve. So I'm going to put a curve, oh, I don't know. Maybe I'll have my vertex here. It's very bright, isn't it? My eyes, my eyes. The sad part is that all my videos have been done on that darn dim projector. Okay, so the tangent line to the curve changes at every single point along the curve. So for instance, at this point, this would be the tangent line, right? At this point. If I change it to this point, now I have a new slope, a new, well, that wasn't a very good tangent line, but you're getting the idea. Here's another tangent line. The only time the tangent line is ever horizontal is at the vertex. Let's assume that I hit the vertex correctly. And then that would be the line tangent at the vertex. And then of course, these are all negatively sloped tangent lines. Then we would start to get to some positively sloped tangent lines. And then off video, I will show you how we derive the formula that we're going to use. But there's an infinite number of points that are on that parabola, and therefore there are an infinite number of lines that are tangent to that curve. So how are we going to find that? So let's look at example 2. You're shocked because you're wondering what happened to example 1, right? I don't know. I would really like that to not be fuzzy, because it's not my imagination. Is that fuzzy to y'all? No, it's not? Oh, okay, well then welcome to my world. Now you know how I feel. Alright, so there we go. So we are going to find the formula for slope. Then we're going to evaluate it, given that the function is x squared plus 1, which is a parabola. Where's the vertex on this? It's at 0, 1, right? We're going to find the formula for slope and then find the slope at 2 different points, 1, 2, and 2, 5. So we're going to kind of do it twice. So we're going to use the difference quotient for this. Remember how much we've been practicing that lately, how much you love it? So use the following. I want you to write yourself lots of notes today. Use the following formula for the equation of the slope at any point. And so these are just 2 of the points. Oh, you didn't tell me you couldn't see it. So we will use m equals f of x plus h minus f of x all over h. Isn't that familiar? Now I will show you how to derive that, as I said, off camera. I'll show you where that comes from. But essentially we took 2 unknown points on the parabola really, really close to each other. Because on this parabola right here, the closer the 2 points are, I mean any 2 points, I'll create a secant line through the parabola, not a tangent line, because technically a tangent line is 1 point. It's touching that parabola at 1 point, right? But the closer I get 2 points to each other, the closer and closer they get, won't they approach the tangent line, or the tangent point? The closer I bring 2 points together, won't they become closer and closer to that point of tangency? So eventually, aren't I going to get a line that's pretty darn close to the tangent line itself? It's just slightly off. So that's how we derive this, and again, I'll show you that later, but off video. All right, so step 1. This is our formula that they gave us, right? So that kind of changes each and every time. So we're going to take that formula and just do the difference quotient, just like we did before. Sean, are you not taking any notes?
I'll have to do this.
I want you to take notes with me. Brain research says you learn more if you're doing. So then if you go back and then watch the video afterwards, then you'll learn some more. But if you don't do it while you're doing it with me, you don't learn as much. So, all right, so then I'm going to use brackets, and I'm going to replace each of the x's in this formula with x plus h. And so this is my f of x plus h right here. And then minus f of x. F of x should look exactly like what we had here. We just replaced an x with an x, so it looks the same. Here I replaced an x with an x plus h, all divided by h. Some of the problems that I saw in your quiz was that you were not, the majority of you are, but some of you are not multiplying this out correctly. So if I FOIL this, x plus h times x plus h, I actually get x squared plus 2xh plus h squared. That's what that binomial is squared. Plus the 1. Then distribute this negative to everything here, so minus x squared minus 1, all divided by h. Then start canceling out the things that you can cancel, so a positive 1 and a negative 1, x squared and negative x squared. That leaves me right here with 2xh plus h squared. So what can I do with that? Yep, factor out an h, 2x plus h all over h, and then the h's cancel. And I'm left with 2x plus h. And then, didn't we find the limit of the function as h approached 0? Okay, so we're going to do the same thing. So step 2, you are going to take the limit, and by the way, this is going to represent our slope formula, but I'm going to write it a little differently. So you're going to take the limit of m, because we just derived, by the way, you just derived your slope formula. So you just performed a derivative. Your very first derivative. I'm so proud of you. Now you know how. Was it that hard? No. So that's where derivative comes from, is you've derived another formula. This is actually f prime, f of x, f prime of x, which we'll talk about different forms of derivatives in a minute, but we'll get on to that later. So you're going to take the limit of m as h approaches 0. So m equals the limit as h approaches 0. And then our function is what we came up with, 2x plus h. What do you do with that? What do you do with that? Plug in 0 for h, right? So we can just do direct substitution. So I've got m equals 2x plus 0, right? So doesn't m equal 2x? There's our slope formula. So in y equals mx plus b, m is 2x. Now, haven't you been given 2 different points? True or false? You've been given 2 different points. So then step 3, that up a little bit. You're going to, if m equals 2x, you can now find the slope at various points. So we're just finding the slope. We're not actually finding the equation of the tangent line. We could do that, couldn't we? If we wanted to. We'll get to that. So one of our points is 1, 2. So what's your x value? M equals 2 times, for the point 1, 2, this is my x value, isn't it? So I'm just going to plug in 1 for that. And oh, by the way, we're missing something because this is the last sheet that you're missing something. That should be a -1. There's a reason why there's a big blank there. So instead we're going to plug in a -1 here. But if it were +1, we'd just plug in +1. It wouldn't matter. What's the slope at that point? -2. Then could it use the point slope formula? Using that point and this slope and come up with the equation of the line that's tangent? There you go. All right, so then the other point, we're still using the same formula, 2x, but this time our x is 2. So we come up with a slope of 4. So we had to derive our own slope formula by using the difference quotient and then finding the limit as h approached 0. All right, so flip it. So these are just different symbols, and if I were you, I would separate them. This I don't know why you wrote all these here. So if I were you, I would separate it here. Here's one type of symbol. You can go from here to here. And then separate it here. And then, yeah, here. You won't see me using these all that much. These are different symbols that you can use for derivatives. You're missing one here. This is supposed to be a prime. I like f prime. So you'll see me using f prime a lot. So you'll start with f of x and go to f prime. So let's find the derivative. You just did it once. All of these just use a difference quotient. So all 3 of them, I want you to go through and find your derivatives. So you're going to be using this right here. So f prime of x is going to be f of x plus h minus f of x all over h, right? So you derive your own formula. What you're doing is you're finding the slope formula. But you're going to have h in there, so you're not going to take the limit yet. Leave h in there. So I'll run through the first one with you, and then you can just ignore me if you like. You're going to have to write small. So all I did was square out the x plus h into x squared plus 2x plus h squared. I haven't multiplied the 4 yet. I'll do that in a minute. Sorry, Kelsey. I caught it that time. It's because she's not here to tell me. So at this point, in fact, I think I'm going to just blow this up a smidge. There. Is that better? What can I start to cancel out? 4x squared. What else? 6x. What else? 3. And then do I have any like terms that are left over? I have 1, 2, 3 terms left over. None of them are alike, right? So what can I do with those? Factor out an h. And so then my h's cancel. And I'm left with a final answer of 8x plus 4h plus 6. There's... yes, I could factor out a 2, but it's not going to do me any good. I see where you're going with that. I really only care about factoring out the h at this point. But you could just leave parentheses. So if we were to find the limit as h approaches 0, what would happen? The 4h term would go away, and wouldn't your slope formula be 8x plus 6? And then for any ordered pair that I would give you, you just plug in for x, the x value, and you find your slope, and then use that point with point slope form to find the equation of the line that's tangent, which we'll do below in a minute. So can I move on to the second one, or are you still working on this one? Did you do that? All right, so move on to the second one. Try that one almost on your own. I'll do it up here. Well, how fun is that? Is that at really x to the 4th? Oh, yay. You just wait. So I'm going to run out of room here. Well, maybe not. So if I were you, I would do, I already know that x plus h squared is this right here, correct? So if you square this, you have a triple distribution. You're going to have 9 terms. Here's what you're going to end up getting. So I'm going to save you a little bit of time. You're going to get x to the 4th. And I'm going to have to run off into 2 lines here. Plus 4x cubed. H plus 6x squared h squared, I believe, yep, plus 4x h to the 3rd. Oh, how could we have done that so much shorter? We weren't thinking. Plus h to the 4th. What's 1, 4, 6, 4, 1? Ah, can't we use that to do this? Pythagorean or Pascal's triangle, yeah. Right? All right, so I would do that. So that's just this raised to the 4th power, then plus, and so that's all with parentheses, then plus, distribute your 2, so we've got 2x plus 2h, distribute your negative here, minus 3x to the 4th, minus 2x. All of that is over h. And then we have to distribute our 3, right? So equals 3x to the 4th plus 12x cubed h plus 18x squared h squared plus 12xh cubed plus 3h to the 4th plus 2x plus 2h minus 3x to the 4th minus 2x. All of that over h. Now I can start canceling. So what can cancel? 2x and 3x, the 3x to the 4th and 3x to the 4th. None of the h's, right? That's it. Am I right? Okay. So then we can factor out what in h? So we have here 12x cubed, and then plus 18x squared and an h, plus 12xh squared, plus 3h to the 3rd, all over h. Plus 2h. Oh, plus 2h. Little bugger got away from me. Plus 2, just plus 2, right? We took out an h. Alright, so then the h's cancel. And our final answer is 12x cubed plus 18x squared h, this is our derivative, plus 12xh squared plus 3h to the 3rd plus 2. So that was a doozy. But how do we make it easy? Well, first of all, we'd have a lot more room, but how do we make it easier? What do we remember to do on this one? Pascal's triangle, right? And expand that so you don't have to actually multiply it out. Everything's coming together. All right, so this one's a lot easier, right? So the derivative is 6 times x plus h squared minus just 6x squared, right? All over h. So square your x plus h, 6 times x squared plus 2xh plus h squared, you should be good at that by now, minus 6x squared, all over h. Distribute your 6x squared, plus 12xh, plus 6h squared, minus 6x squared, all over h. Now what do you do? Cancel. Sean, are you with me yet? Factor out your h. H times 12x plus 6h all over h. Your h's cancel. And we're left with 12x plus 6h. Right? No different. All right, so how are we going to use that? So look at the last example. The last example, we have 4 things that we're going to do. Thing number 1, you're going to find the derivative. We just practiced that, right? Thing number 2, you're going to find the slope at certain points. That's what we did on the other side. So this is the point that I've given you here, which is 4, 3. And thing number 3, find the equation of the tangent at that point. So the line that's tangent, we're going to do that with the point slope formula. And then the last thing is to find the point where the tangent line is horizontal. You are missing, obviously, a negative here, right? So it should be 3x squared minus 2x. So let's do thing 1. So my numbering here deals with thing 1. So we're going to find f prime of x as the limit of h approaches 0. So this time we're actually going to find the limits of f of x plus h minus f of x all over h. So find the derivative. You do that. How are we doing so far? What do you get that from? What can I cancel? 3x squared. What else? 2x. And that's it, right? So then factor out your h. And so it equals 6x plus 3h minus 2. Okay, so that's the derivative, okay? So you might want to note that this is step A to finding, well, we haven't actually found the whole derivative. We found our slope formula, and we're going to find the limit as h approaches 0. So step B, we're going to find the equation of the slope. So slope is equal to the limit as h approaches 0 of 6x plus 3h minus 2. Use direct substitution. So you've got 6x plus 3 times 0 minus 2. What do you end up with? Slope is equal to 6x minus 2. And that's not the equation of a line. I know it looks like it, but it's not. That's the equation of slope itself, just m. So now we've accomplished thing 1. We've found the derivative. This is your derivative. You just derived a new formula. Then step 2, you're going to find the slope at a certain point. So the point that they gave us right here was 4, 3. This is our x value, this is our y value. So step 2, you're going to just plug that into slope. So m equals 6x minus 2. We're just going to plug in for x. That's all we care about. X is 4. What's 6 times 4? Minus 2? 22. So our slope is 22. Then step 3, you're going to find the equation of the line tangent at that point. So you're going to use point slope form. To write the tangent equation. So in case you forgot, do you remember what point slope form is? Y minus y minus y sub 1 equals m times x minus x sub 1. Some of your algebra teachers rarely use this, unless you're given a point and a slope. I use it all the time. So you're going to substitute only in for x sub 1 and y sub 1 and for slope. The plain x and plain y stay alone. So I've got y minus, and then my y sub 1 is 3. If it were a negative, it changes that minus to a plus, right? Equals, my slope we just determined was 22. And the slope changes at every point. So the slope will not always be 22. If I change the point, it changes the slope. And then the x sub 1 is 4. Is everybody clear as to where I got those numbers? And then you're going to write it into slope-intercept form, which means you're going to solve for y. So distribute your 22. So we get 22x minus 88. And then add 3. If I add 3, I end up subtracting it, so don't I get minus 85? So it's a very steep slope, is it not? Very steep slope, up 22 to the right 1. Crosses the y-axis at negative 85. And then the last thing, they want you to find the point where the tangent line is horizontal. So you might need a little bit of room, so let's do it over here to the right. So step 4. What did I say about when the tangent line is horizontal? It's at the vertex. We need to find the vertex. What I do know is that the slope at the vertex is 0. And don't I know what the slope formula is at every single point on that curve? So I know a little bit. So write yourself a note. The slope of a horizontal line equals 0. The only place where the tangent is horizontal is at the vertex. So we're going to start with our slope formula. M equals 6x minus 2. What do I know about the fact that the tangent's horizontal at my vertex? Because what they're asking me is to find the vertex. What do I know about the slope at the vertex? It's 0. So can't I replace m with 0? And won't that give me one variable to solve for? So solve for x. So add 2. 2 is equal to 6x. Divide by 6. So if I divide by 6, I don't get 3, do I? I get x is equal to 1/3. Not a happy answer, but an answer nonetheless. Now if I know that my x vertex is 1/3, how do I find the y value of the vertex? Plug it in where? Plug it into the original function, this function right here, right? If x is 1/3 and I plug it in here, won't f of x give me y? So then the next part is plug it in the function. So I'm using f of 1/3. Can't see it. Thank you. F of 1/3 is equal to 3x squared minus 2x. That's the original function. So 3 times, wherever I have an x, I'm putting in 1/3. I need to square the 1/3 first, so I've got 3 over 1 times 1 over 9 minus 2 times 1/3, isn't that 2/3? Doesn't the 3 cancel into the 9 3 times? Don't I really have, I said it wrong, but I did it right. 3 cancels into 9 3 times. So does that leave me with 1/3 minus 2/3? What does that equal? Negative 1/3. So isn't my ordered pair 1/3, comma, negative 1/3? That's my vertex. That was a bunch of questions in one, but they all kind of relate to each other. Any questions about that? Are you overwhelmed or just tired? Does it make sense? Yes or no? Ish.